Hello to my fearsome foursome. I think that's what I've decided to call you ladies, and I'm especially recognizing today Shiloh's girl. Shiloh's, I guess it would help if I knew what the screen name was. Anyway, we are going to go ahead and do section 2.1. And section 2.1 is simple. It is solving linear equations, just a review of what we've been doing already for a long time in Algebra 1. It gives us a review of some vocabulary and then makes the equations just a little bit more involved, but not hard at all. This should be something that is very easy, very straightforward for you girls to do. But first, just for you, Shiloh's girl, why did the dog cross the road? Well, he crossed the road to get to his barking lot. So we are on page 42 in our text, and we're just going to get into solving linear equations. And we remember that once you put an equal sign in an expression that you have, right here, this is just an algebraic expression. And you can have an infinite number of values for an algebraic expression that is dependent on what the value of your x variable is. If x is 2, it's a 6. If x is minus 1,000, the answer is minus 998. But as soon as we put an equal sign in here, we limit the total number of solutions, total number of possible choices for our x value to simply 1, because this says that our equation is in balance. It's like that seesaw or 2-pin balance bar. What you have on the left side of the equation has to be exactly the same, exactly equal to what you have on the right side of the equation. And we've learned, of course, to solve for x and say that x is equal to 4. So this is what linear equalities are. It's just a first-degree algebraic expression that we can solve and find out what x is equal to. And we also remember that they're called linear equations because what these equations really are the algebraic definition of a straight line. And we'll be doing that graphing later. But for now, there is just a little bit of review of some terminology. We have properties of equality. And some of these definitions, we haven't used this exact word for them, but you'll recognize the property. Properties of equality. We have the reflexive property. Reflexive. With these properties of equality that we're talking about, we are assuming that the values represented by A, B, and C are all elements of the real numbers. In other words, we're not dealing with complex numbers here. It can be an integer, it can be a whole number, it can be a rational number, it can be irrational. But it does have to be a real number. So first we have the reflexive property, and where did I put the reflexive property tells us that A is equal to A. You would think that everybody would know 4 is equal to 4, 2 is equal to 2, x squared is equal to x squared, but we have to define that anyway. We have the symmetric property. Symmetric property, and this says that if A is equal to B, then B is equal to A. If A is equal to B, then B is equal to A. That's where we have the mirror image. You know, when you look at yourself in the mirror, it's still you, but it's in opposite direction. Then we have the transitive property. Transitive tells us that if A is equal to B, and B is equal to C, then A is equal to C. And we're going to use this concept a whole lot just in reasoning, in logic, in argumentation. But this is something, if this is true, and then what you've the next statement is true, then what you said the first time has to be true as well. For example, let me see if I can think of one in logic. All flowers, oh, I should not have done this. All flowers, let me see, wrong way. All roses are flowers, All flowers have petals. What do you need? Okay, just a minute. Have petals. If roses are flowers, A is B, and flowers have petals, then what? All roses have petals as well. But that's what the transitive property is, and I'm going to let a couple of boys in here. The camera's still on. Just go ahead and pull your stuff out. Okay, another property that we have is the addition property of equality. And these are properties of the equalities. If A is equal to B, and you can say then that if you add C to A and B and C to B, then you have not changed the value of your original statement. If A is equal to B, then A plus C is equal to B plus C. And then you also have the multiplication property of identity. I'm going to go ahead and get out my little logic statement over here. Gone. And we have the multiplication property of identity. Multiplication. And this tells us that if A is equal to B, if we have two different statements that are equal, if A is equal to B, then A times C is equal to B times C. So this is just a review of the properties of equality. Make sure you know what it means when we say reflexive, symmetric, transitive, multiplicative, additive properties of identity. So now let's go ahead and roll right along with, if I can figure out what I did with my eraser, roll right along with solving some linear equations. And I'm serious, you're going to just love this because it is so simple. You've been working on these for a very long time. These are just old hat too. If we're going to solve x plus 8 is equal to 26, I'll throw that one out. In order to solve an equality, you want to isolate the variable on the left-hand side of equality, on the left-hand side. So we've added 8. If we subtract 8 from both sides of the equation, doing the same thing to both sides of the equation's still in balance, and you're going to end up with x is equal to 16. See what I meant? This is just a very, very quick, easy review for you. The next equation that we want to go ahead and demonstrate for you right here is, let's solve 5x plus 12 is equal to negative 18. When you're solving these equations, all you have to do is, we don't care about 5x. We don't care that 5x plus 12 is equal to a negative 18. All we're trying to do is figure out what 1x is. So we have to isolate our variable, which means first, we're going to isolate the term that has the x in it. We've added 12 here. If we subtract 12 from both sides of the equation, it's going to help us a lot. Let's see what happens. So we have negative 18 minus 12. 5x plus 12 minus 12, you simply have 5x is equal to negative 18. You go 12 units further to the left on the number line, negative 30. We have 5x is equal to a negative 30, but we won't care about 5x. We only care about 5. So one way to solve this is to divide both sides of the equation by the coefficient of the variable. The other way that you can solve this problem is by multiplying both sides of the equation by the coefficient. I do not mean that. By the reciprocal of the coefficient of the variable. Then you have negative 30 times 1 over 5. Remember, when you take the reciprocal of something, you have it in not exponential, you have it in rational form, so that it looks like a fraction. You turn it on its head. If you have a whole number, you just divide it by 1. And what's nice about multiplying by the reciprocal is then you simply cancel common factors. We have a common factor of 5 that cancels on the left-hand side. We have a common factor of 5 that cancels on the right-hand side of the equation again. So, as you would certainly expect, we have the same answer, same value for x, which is a negative 6, regardless of how you solve your equation. What do you need? I expected you to get it when you were just in here. Okay, so let's go ahead and see what our next value is. Next expression is that we want to evaluate. We have problem number 3. Before we do this one, let me read what they have here. This says, the key to solving equations is to consider the order in which operations affect the variable. To solve the operations, you have to do the inverse order. You have to do the inverse operations in reverse order to both sides of the equation. We've got the distributive property that we want to do first. And I really think they're trying to give you some math terminology that honestly is not so necessary for you to have. We want to solve this equation. Here we have 6 times the quantity x plus 4 plus 3x is equal to 105. Okay? Well, once again, we only care about what one value of x is. And we have a little bit of a mess here on the left-hand side. So before you can figure out what 1x is equal to, we're going to have to apply the distributive property here. 6 times x, 6 times 4. So you have 6x plus 24 plus 3x is equal to 105. We still have a mess on the left-hand side of the equation. So we are going to combine like terms. 6x plus 3x, 9x. 9x plus 24 is equal to 105. We don't care about 9x plus 24. We're trying to figure out what 1x is. So we have to isolate the term that includes the variable. We want to have 9x. Well, we've added 24. Now what we're going to do is subtract 24 from both sides of the equation. When you subtract 24, you have 9x is equal to 105 minus 24, which is 81. Now, isn't that convenient? See, they work these problems so that the majority of the time at this level, you're going to end up with some very straightforward arithmetic at the very end. And we figure out that x, with a value of 9, makes this equation true. So let's just think through the check. What is 9 plus 4? 9 plus 4 is 13. 13 plus 6 is 78. 3 times 9 is 27. So we have 27. And you see that when you substitute in the value of 9 into this original equation here, you do end up with 105. Now this right here, that's just a quick and dirty check to make sure that you've got what your solution actually is. Okay? Then I have a very visible location here at the library. It's the one that has glass on two sides of it. So I'm getting all sorts of interesting looks as people come by and see me happily talking to this camera. But you know what? I'm really excited because God showed me the way to make a big blackboard at home. I can get, I don't even remember what they call it, but I buy a 4x8 sheet of it at one of the home improvement stores, cut it off at 6 feet, slap it on the wall. At some point we'll put a decorative border around it. And thank you, Jesus, I have a nice long board for us to work with. Okay, moving on to page 44. Now, remember what I've talked about for, I don't know how many times, is when you have a negative that you're distributing, that's one of your easiest ways to get trapped or to get caught up. When you really understand what your equation is, you're understanding the process completely, but what can tend to happen is that you drop the negative sign and then you're just so frustrated because you did the work right, but you missed the negative. 4x plus 71. This is a little bit more involved of a linear equation, but it's well within all of you guys' capacity to do. We have values of x on both sides of the equation. We want to get those x's on either the left side or the right side. What do we have to do first? We're going to have to distribute this -3, but we've got the negative sign. So we have -3 times x, we have -3 times a +2. And remember, when you distribute a negative sign, it's going to have the effect of changing the signs of every term that appears within those parentheses. -3 times a +x, -3x, -3 times a +2, minus 6 is equal to 4x plus 71. Now I want to go ahead and glance in here at the book for just a minute and see how they're going to have you do this. Yes. Now, just a second ago I said we're going to want to have the variable x on one side or the other. And when you're first beginning to work with solving linear equations, we just put the variable on the left-hand side, put the constant terms on the right-hand side. But I have this thing about multiplying or dividing by negative numbers. I would just soon not do that, not introduce that additional possibility for error. So what I like to do is move my variable to whichever side of the equation will make it so that I have a positive here. Now look, I've got a -3x. If I move this 4x over here, I'm going to have -7x. I'm introducing more potential for error, but my x's are going to be positive on the right-hand side. So what I'm going to choose to do this time, you don't have to do it. You can solve for your variable on either side of the equation. Remember, we said if something's equal, it doesn't matter if it's this way or if it's this way. You know that the equation is still in balance. So what I'm going to do is put my x's on the right-hand side, my constant terms on the left-hand side. You can do it whatever way you want. So you can actually show your work in one step where you're dealing with the constant terms, dealing with the x's at the same time, but just to do it at the basic level, I'm going to do an extra step. First, what I want to do is I want that 71, don't want any constant terms on the left-hand side of the equation. So in order to do that, I'm going to have to add, that's a positive. I'm going to have to subtract a 71 from both sides of the equation. So what happens when I subtract the 71 from the right-hand side of the equation? Well, I have my 4x all by itself. And I want you to get in the habit always of beginning your writing at the left side and going to the right side. And the reason for that is sometimes when you're factoring and you factor out a constant term all by itself, no variables, if you're not in the habit of writing down your entire equation from left to right as you're solving, you can tend to drop those constant term factors, which is just not nice. So now we have minus 3x, combine this, minus 77 is equal to 4x. And you see that the answer is already, you're beginning to see that, oh, the answer is going to be 11, negative 11, because they manipulate these equations artificially so they're easy to do. The arithmetic, we want our constant term on the left, we want our variable term on the right. So if we have a negative 3x over here, we're going to have to add a 3x to eliminate the variable from the left-hand side of the equation. And of course, if you've added a 3x to the left side of the equation, then you also have to add a 3x to the right side of the equation. Negative 77 is equal to a positive 7x. We divide both sides of the equation by 7, and you have that negative 11 is the same as x. Or x has a total value of negative 11. If you took the time to put this value back in here and work through it, actually solve it where you don't have the variable but you have the value of negative 11, you would see that the number on the left-hand side is the same as the number on the right-hand side. And that is example number 4 from the book. Let's look at example number 5, which is the final example. From the text. Okay, we have several parentheses involved here. This is example 5. We have 3 times the quantity x plus 2 plus 5 times the quantity 2x minus 7 is equal to 4x minus the quantity 2x plus 3. Okay? We have several parentheses, means we're going to have to apply the distributive property 3 separate times. 3 times the quantity x plus 2 is going to give you 3x plus 6 plus 5 times the quantity 2x minus 7. 5 times 2x is 10x. 5 times the negative 7 is negative 35. All of that now is equal to 4x minus the quantity. We're distributing a factor of negative 1. So when we remove those parentheses, you have minus 2x minus 3. Be careful. Watch out for those negative signs. Make sure you don't drop the negative sign. You cannot just remove the parentheses because then you'd have a positive 3, wouldn't you? It's not what you need. Combine like terms on both sides of the parentheses. 3x plus 10x is 13x. Negative 35 plus 6 is negative 29 is equal to 2x minus 3. What I'm going to do now, 2x is positive, 13x is positive. I'm going to move my variables to the left-hand side. Now, how about if I combine 2 steps, just because I can. I want all of the x's on the right-hand side, so I'm going to have to subtract the 2x from both sides. I want all of the constant terms on the right-hand side, so I'm going to add a 29 to both sides of the equation, and I'm going to do that at the same time. So I have 13x, I have to subtract 2x, minus 2x. Negative 29, I want to be able to move that over to the right side of the equation. plus 29 is equal to 2x. What did I do over here? I have a negative x. I'm sorry, minus 2x. I've subtracted 2x from both sides of the equation. And I've also added 29. Minus 3 plus 29. 13x minus 2x is 11x. Negative 29 plus 29 cancels. 2x minus 2x cancels. Negative 3 plus 29 gives me a 26. That's a strange number, but it's going to be okay. Actually, it's not a strange number, it's just not a perfect number. 11x is equal to 26. I can either multiply both sides by the reciprocal 11 of 11, which is 1/11, or simply divide both sides of the equation by an 11. Since there's nothing here, there's a common factor, it's just as quick to divide both sides of the equation by 11. That's what we have involved here. That's all section 2.1 is. This is a nice breather for you. Nothing difficult, nothing hard to remember. You know, they're doing awesome. I'm so blessed to be able to be working with you.